Imagine, for a moment, the quiet hum of the cosmos. Our solar system, a delicate cosmic clockwork, ticking along as it has for billions of years. Earth, a tiny blue marble, basks in the life-giving warmth of its star, the sun. We go about our days, connected, powered, and guided by a web of technology we take for granted. We stream, we navigate, we communicate across continents in an instant. Our world is a symphony of digital signals, a testament to human ingenuity. But what if the very star that gives us life decided, one day, to take it all away? What if the calm was just a prelude to a storm, not of wind and rain, but of fire and magnetism? A storm that could send us back to the Dark Ages. This isn't just science fiction. It's a story that has happened before and will happen again. It begins, as most disasters do, without warning. On the surface of the sun, a tangled knot of magnetic fields, larger than a dozen Earths, writhes with unimaginable energy. Deep within this stellar cauldron, pressures build to a breaking point. And then, it happens. A colossal explosion, a solar flare of biblical proportions, erupts from the sun's surface. It's a blast so powerful it dwarfs all the nuclear weapons on Earth combined, detonated at once. A torrent of charged particles and radiation, a coronal mass ejection, is hurled out into space. A wave of cosmic fury, traveling at millions of miles per hour, and its destination. A small, unsuspecting planet, third from the sun. Its destination is Earth. Within hours, the first particles arrive, painting the sky with an eerie, beautiful, and terrifying light. Auroras, the ghostly curtains of the northern and southern lights, are no longer confined to the poles. They blaze across the night sky in Cuba, in Hawaii, in places they have never been seen before. People stare up in wonder, capturing the impossible spectacle on their phones. But this celestial light show is a harbinger of chaos. As the main bulk of the solar storm slams into our planet's magnetic shield, the magnetosphere groans and contorts under the assault. On the ground, the first signs of trouble appear. Phones flicker, GPS signals become erratic. Digital screens glitch with static, displaying alien patterns. The invisible network that holds our world together is beginning to fray. This might sound like the plot of a disaster movie, but this is a retelling of a true story. The year is 1859. The world is connected not by fiber optics, but by iron wires. The telegraph is the internet of its day, a marvel of communication. On September 1st, a British astronomer named Richard Carrington is sketching sunspots when he witnesses a brilliant flash of light on the sun's surface. He has just become the first person to observe a solar flare. Less than a day later, the storm he witnessed hits Earth. Telegraph systems across the globe go haywire. Sparks fly from the equipment, shocking operators. Some telegraph stations catch fire. Bizarrely, some operators discover they can disconnect their batteries and continue sending messages, powered solely by the auroral currents surging through the wires. It was the largest solar storm ever recorded, the Carrington Event. Now, let's travel back to our time. What if a storm of that magnitude hit us today? The 1859 event was a curiosity, a disruption. In our hyper-connected, technology-dependent world, it would be a catastrophe. Imagine waking up one morning to find your phone is a useless brick. The internet is gone. Not who's slow, not just down for an hour. Gone. The satellites that form the backbone of our global communication, navigation, and financial systems are fried by the intense radiation. They tumble silently in orbit, their electronics scrambled beyond repair. GPS is a memory. Credit card transactions fail. The stock market, a river of digital data, freezes solid. The world's economy grinds to a screeching halt. But the real crisis is just beginning. The solar storm induces massive electrical currents in the ground, not just in telegraph wires, but in the sprawling power grids that light our cities and run our lives. Transformers, the hearts of the grid, begin to overheat and explode. One by one, they fail, triggering a cascading blackout that plunges entire continents into darkness. No power means no light, no heating, no air conditioning. It means the pumps that deliver clean water to our taps stop working. The systems that keep our food refrigerated fail. Hospitals are thrown into chaos as backup generators, designed for short-term outages, eventually run out of fuel. Modern cities, these brilliant jewels of civilization, become traps. Without power, transportation grids collapse. Electric trains are stranded. Traffic lights go dark, causing gridlock. Gas stations can't pump fuel. In a matter of days, the intricate supply chains that feed our populations are severed. Supermarket shelves empty. The foundations of modern society, built on the assumption of constant, reliable electricity, crumbled. It's a world plunged into an unnerving silence, broken only by the whispers of the wind and the worried voices of neighbors. We would be forced to rediscover a world without the instant connections we've always known. A world where news travels by word of mouth, where communities must band together to survive, and where the night sky, free from the glare of city lights, is filled with a terrifyingly beautiful silent aurora and more stars than we've ever seen. The Carrington Event of our time wouldn't just be an inconvenience. It would be a global reset, forcing us to confront our fragility and our profound dependence on the invisible systems that power our lives. It's a sobering thought, a reminder that we live on a rock, orbiting a volatile star, in a universe that is both beautiful and indifferent to our existence. But our story doesn't end in darkness. Humanity is not a species that waits idly for disaster. In observatories and control rooms around the world, scientists are our sentinels. They are the modern-day Carringtons. Their eyes fixed on the sun, using an array of space-based and ground-based telescopes. They monitor our stars' every mood swing, every flicker of magnetic energy. They are the forecasters of space weather, giving us precious hours or even days of warning before a solar storm arrives. This warning is our shield. It gives power grid operators time to take preventative measures, to reconfigure systems and disconnect sensitive equipment to minimize damage. It allows satellite operators to put their craft into a safe mode, protecting their delicate electronics. It's a race against time, a high-stakes chess game against the raw power of the sun. And in the aftermath of our hypothetical storm, as the auroras fade and the sun returns to its quiet state, the long process of rebuilding begins. It would be the greatest engineering challenge in human history. We would replace the fallen transformers, relaunch the silent satellites, and painstakingly restore the global networks that bind us together. Life would slowly, painstakingly return to normal. But we would be changed. We would have a newfound respect for the star we orbit, a deeper understanding of our own vulnerability. We would build smarter, more resilient systems, hardening our technology against the fury of the cosmos. The great solar storm would serve as a powerful, humbling lesson. It teaches us that while we may be masters of our digital domain, we are still subject to the grand and sometimes violent cycles of the universe. Our sun gives us life, warmth, and energy. It's a source of wonder and inspiration. But it also demands our respect and our vigilance. And so we watch, we learn, and we prepare. Because the sun will storm again. It's not a question of if, but when. Thank you for watching. If you found this journey thought-provoking, consider subscribing for more stories about our amazing and powerful universe.